Right. So actually, the topic that we are going to study today is a completely different topic. It's not a part of Unit 1. I'm jumping directly to the middle topic of Unit 2, that is IP addresses. But as far as I have discussed with you, I think uh, I should explain this topic first and then again go back to Unit 1. So, sorry if you uh, uh, don't understand few things. Please uh, do ask me the queries. Okay. So, so the topic that we are going to study here is IP addresses. Okay. So basically, what IP address is, for each machine you have to configure one address. And we are going to study how that IP address is prepared, what are the basics behind that addressing. Okay. Uh, so a complete IP address is a 32-bit length long address. Okay. If you consider a binary value, it has a 32-bit wide data. Okay, so whatever the IP address, let's say 192.168.1.1. Okay, so this is a, for example, this is a IP address. So how this IP address is prepared? So the length of this IP address is first of all 32-bit. Now, let me give you the idea here. Okay, before we go ahead. Now we have talked about the computer networks. Let's consider there are multiple networks. Okay. Uh, this is your home network. This is the network in which I am sitting in. Okay. And this is some other network. Okay. So basically, the computers which are configured in these networks, okay, will have some IP addresses. Okay. So if you want to, let's say, reach at any machine in the internet, what you have to do is you have to find the particular path, okay, and route the data towards the destination network. Okay, for that, what you have to do is each IP address you should know. Okay, every machine is configured with IP address, internet protocol IP address. So this IP address, for example, it is 192.168.1.1. Okay, this is one IP address. Let's say another IP address is 172.20.13.15. Okay, I'm just giving hypothetical one machine's IP address. Okay, and so on. Let's say this is 10.1.1.1. Okay, this is 30.1.1.1. Okay, now we should understand how to reach a particular network, and then once you reach the particular network, how to reach a particular host. Okay, so these are the two things which are important in this session. So consider here this as a society, okay, or this as a building. Okay, building A, building B, C, and D. Okay, Now, let's say if you have if you want to go to a particular flat in a building A, what you do is you get the flat number as 514. Okay, so in the building A, so what will you do? On which floor you will reach?
Fifth floor.
Fifth floor. Okay, and obviously on the fifth floor you will find the 14th flat number, right? So this is very important. As soon as you get an address, okay, first of all you have to find out from which group uh, you should be reaching. Once you reach that group, okay, because on each floor there is a flat number 14, but a particular flat is differentiated with a floor number. Okay, so similarly every IP address also has two different parts. One is the network part and the other is the host part. Okay, so network part is similar to the floor number. Okay, and the host part is similar to the flat number. Okay, now when we apply this same concept in the network will identify, you know, what is the network you are trying to reach, and in that network which is the host part, or which is the machine or a computer that you want to address. Okay, so some part will identify the complete network and some part will identify a particular machine. Okay, got this concept? So this is a complete IP address, and the length of this IP address is a 32-bit. Okay, now the division is not the exact, the half part is not the network and half part is not the host. The division is further classified in these classes. Okay, so there are three classes of IP addresses. The first one is class A, the second one is class B, and class C. Okay, so total there are 5 classes, but these 2 classes, class D and E, are not used, okay, by anyone in the world. For the normal use, class D is used for multicasting and class E for research. So it is specifically given for the study purpose. Okay, we'll have to work on these 3 classes only. Okay, so what is class A? First of all, this IP address is divided into 4 sections. Okay, and equal 4 sections, so 8 bits each. So 32-bit complete IP address is divided into 4 parts of 8 bits each. Each part is called as octet. Okay, so if there is only one network section, one octet which is identifying the network, and all other 3 octets are identified by the host. Okay, so the division of network and host is like this. Okay, for class A. For class B, 2 octets network, 2 octets host. For class C, 3 octets networks and only 1 octets of host. Okay, so this is the division of classes. Now, if you identify, 514 is one example. If you have something like this, if it is the same thing, let's say if these 2 are the floor numbers, that is also possible, and this is the flat number. That is also possible, right? So first two bits or first two digits identifies the floor number, and this can be identified as a flat number. Consider a building which is so long in a height, and on each floor there are only 4 flats, something like, and it has 90 floors. So in that case, you will divide or you will assign the flat addressing like this. Okay, usually in a normal 8 floors or 10 floors, you find this kind of division, 504 or 5518 or something like that. In that case, you say that this is the floor number and this is the flat number. But this is also a possibility of addressing a particular flat. Okay, so how the address is divided to identify the network and the host, that is given by class A, B, and C. Have you understood this concept? Any doubts? Okay. Now, as you can see here, only one section is the network part. Okay. That means how many bits are there? 8 bits for network. Okay. So how many such networks you can have in class A? For class A, how many network bits are there and how many host bits are there? And number of networks that you can have and number of hosts you can have in each class. Okay, that we'll find out. So what are these are the number of bits. Okay, so in class A, 8 bits networks, and remaining, how many bits are there? Total 32 bits. So how many host bits are there?
24.
24. So the total IP address is 32 bit. Okay, out of which if you are assigning 8 bits as network, then remaining 24 bits are host bits. For class B, it is equal division, 16-16. Okay, because two octets are assigned to network bits and 2 octets are assigned to host bits. Each octet is of 8 bits. So that's why 16:16. And in class E, 24 bits are network bits and only 8 bits are host bits. Okay. So now with these number of bits, how many number of networks that you can have? That means what? If you want to see it as, if you are assigning only one digit to a floor identifier, so how many such floors you can have?
8
or 9. You can maximum
so zero will be
digit
also
that you can
counted.
have is 9. For one digit, the maximum digit you can have is 9. So you can have 9 floors max. If your building is of 10 floors, you cannot say that with one digit you can have address the 10th floor. Okay, for that you have to go with the another format, right? So this is what I want to find out. What is the maximum number of floors if you are assigning one digit? What is the maximum number of floors if you are assigning 2 digits? Okay, so similar concept we'll apply here. I'm sorry. What is the maximum number of networks you can have in class A? So as simple as that, it is 2 raised to 8. Okay. And number of hosts, obviously 2 raised to 24. Okay. Similarly, for class B, 2 raised to 16, 2 raised to 16. For class C, number of networks are 2 raised to 24, and number of hosts are 2 raised to 8. Okay. So this is a rough calculation. This is not the exact calculation. Okay. Rough calculation is because there are some bits which are, completely assigned or fixed. They are not variable. Okay. So I'll come to that part, but this is the rough idea. So 2 raised to 8, around 256 networks you can have with a class A. Okay, and remaining like 2 raised to 24, that becomes, I think, can someone tell me what is 2 raised to 24? Two raised to 10 is 1024. 2 raised to 11 is 2048. 2 raised to 12 is 4 GB. Something around 16,000. Yes, what is the number 2 raised to 24?
16,777,216.
Okay, so some number. It's a quite a large number. So that many computers you can have per floor. Okay, so this is what you are getting. How many such floors you can have? So you can have 256 such floors, and on each floor, how many flats you can have? So that is whatever the digits you whatever the number you have just told me. You can calculate that, but that is a rough number. Okay, we'll come to the exact number in a while. Okay, but have you got this idea? Now it depends on you which IP addressing you will use. Okay, whether you will use class A, class B, or class. Okay, if you have, let's say, an organization in which, let's say, there are multiple departments. There are so many departments in an organization, but for each department, there are very few machines you are configuring. Okay, so let's say in each department, there are only 10 to 50 people who are working, and for those people, only 50 machines are configured in one department. But like this, there are thousands of departments. Okay, so in that case, what is the requirement here? You have larger number of networks and less number of hosts. So in that case, you will use class C because that is your requirement. But what if you have less number of departments, but per department you have plenty of employees working in one department? Let's say you have only around 10 to 15 departments, but in each department there are thousands and thousands employees who are working in one department. So in that case, we'll go with the class A. Okay, where this combination is there. So choosing a class, which class IP address you will use for your organization, is another trading depending on number of networks and number of hosts that you want to have. Okay. Now we'll go back to the PPT. Right. So how to identify a particular class? If I give you the IP address, how will you identify from which class it is? Okay. So for class A, the first bit is always 0. in the 32-bit IP address, 32-bit address, the first bit is always a 0. Okay, so it is completely fixed. So if you have a first bit as 0, that means it is from class A. Similarly, for class B, first 2 bits are 1, 0. So you get any IP address. If the first 2 bits are 1, 0, that means it is a class B. Okay, and similarly for class C, it is 1, 1, 0. For class D, this is what first 4 bits, and for class E, first 4 bits are all 1. Okay, so this is the technique to identify a particular class from an IP address. Okay, so once you have fixed this bit, obviously the number of networks will be reduced. Okay, we have calculated number of networks from all the 8 bits. But if you can't change this bit, if you change this bit to 1, that means you are changing the class. Okay, that means you can't change this bit. So remaining bits are available are 7 bits. Okay, for class A. So we'll go back to this one. So now actual number of network bits are 2 raised to 7. Okay, but still it is not the exact number. I will come to that also a bit later. Okay, so 7 bits are remaining for network bits, and all host bits are intact, all 24 bits. Okay, so if you have an IP address with first bit is always 0, okay, you cannot have the network bits as all zeros. Okay, so for a valid IP address, there should be some value in the in this octet. Okay, and what is that minimum value? So if I give it as 0, so first bit is always 0, 4 bits. I cannot have all the zeros in the first octet. So I'll have to keep one number, minimum number. So this becomes what you can say, the first IP address or first address in the first octet. That is 1. So this is a binary format. If I convert it into digit format, the value of it is 1. Okay, so that becomes the minimum value. What is the maximum value you can have? If you want to calculate the maximum value. Yes, correct.
Sir, the first bit 0 and all 1.
All ones, right, correct. So what is that value in digit? See, 2 raised to 8, that means all ones, correct? Sorry? It is 128. Is it correct?
So it should be 127, right?
127, okay. So that's it. So this is what the maximum value you can have in first octet. Okay. So if the first octet value lies between 1 to 127, okay, that means it is a class A. Okay. So I have given the IP addresses here. So if the IP address is given like this, that means what? It is a first octet value lies between 0 to 127. Sorry, 1 to 127. So it is a class A network. Okay. So similarly for class B, if the 10 is value is fixed, what is the maximum you can have? 128 to 191. So how will you calculate that? So if the first two bits are 1 0, then you keep all the 0 values in the first octet, and in the second octet also all zeros. What will be that number? What is this number? This is 1 and all zeros. These are 16 bits. So there is a
2 raised
division
to the
of,
power 15.
sorry?
So 2 raised to the power 15.
No, that is the total number. 2 to the power of 16 is the total number. What I'm asking you is, what is the octet value? We are trying to find out the octet value.
128.
Correct. 128.0.0.0. All I'm keeping all the values as 0. So this is my minimum value that I can have. Okay. What is the maximum value I can have in the network part?
So the first 2 bit 1 and 0 and all 1.
Correct. First 2 bits are fixed and all ones, all remaining ones. What is that value? At least tell me the first octet value. So if you calculate that, it will be 191. Let's not waste the time in calculating this one. Okay. So when we do the calculation, this will become the range in the IP address range. So 128.0.00 to 191.255.255.255. Now 255 means what? All the bits are 1 in that octet. So when you make all the bits as 1, it becomes 255. When you make all the bits as 0, it becomes 0. I'm talking about the digital conversion. Okay, digital representation. This is the binary and this is the digital. So this becomes the range of class B. For class C, it is 192.2223. Okay. So what I will do is I'll share this PPT again with you. You can just go through it a bit later, just to revise what is the IP address range that you can have for any classes. Any doubts here, guys? Okay. Now, if you have understood this, so again, this is similar representation, how to calculate the IP address range. Okay. And I'll tell you about this concept a bit later. Let's say, not a bit later, let me tell you straight away. There is an IP address 127.0.0.1. Okay. Have you heard about this IP address? Do you know anything about this one? Okay. This is called as loopback address. That means what? Let's say you are not connected to any network, but you have a LAN card. Okay, so you have a standalone machine. You are not connected any cable to this machine. Okay, or it is not connected wirelessly also to the internet. Okay, there is no internet on this machine, but there is a LAN card. Okay, and if you want to check whether that LAN card is working properly or not, or if you want to let's say install Apache web server or XAMPP web server. There are some web servers which you can install on your machine and work on client server architecture. Okay, if you see if you learn Java programming ahead, you'll come to know about this. So what happens is they all use the concept of local host. Okay, that means what? Your machine will become a server for your own machine. Okay, and for that particular address is assigned. Okay, that is called as loopback IP address. So you are not connected to any network. You are, talking to yourself only. Okay, this is your own server and this is your own client. In that case, you don't have to work with any other IP address. You have to work with this IP address. So this IP address, 127 IP address, is dedicated to loopback concept. So you are looping to yourself. Okay, that's why this IP address is not used by any class. Okay, so that's why the class A range is reduced by 1. So previously it was calculated as 1 to 127, but now as 127 is used specifically for one purpose, class A final range becomes 1 to 126. Okay, and other ranges are fixed: 128 to 191, 192 to 223, and so on. Okay, just because of the values of the first octet. Okay, so this is the binary representation and this is the decimal representation. Okay, so now if the problem is given as let's say this is a network address. Okay, now let me give you the concept of what is the network address and what is the IP address. Now let's say what is the problem given here. Problem says that the network address is given. Okay, what is the network address? The 17.0.0.0. Okay, now if you look at the value of the first octet, what is the class that we can identify here?
Class A.
Class A, because it lies between the range, that is the first one, class A. Okay, we are talking about the first octet. Okay, but if you notice, that means in class A, immediately what you have to do is you have to find out what is the network bit and what is the host part. Okay, if it is a class A, that means 8 bits are networks and remaining 24 bits are host bits. If you notice, all the host bits are 0. Okay. Have you noticed a flat number as 500 in any addressing or any address? You'll go to 5th floor and you don't have a value here. There is no 00 flat number. So always what happens is flat number starts with some digit, 501, 502, and so on. Okay, so there is no concept of all the 0 values assigned to a particular flat number. Okay, so this is the normal consideration in a flats addressing. It might be not correct in some cases, but what happens is when you talk about the IP addresses, you cannot assign all zeros to any host. As soon as all the host IDs or all the host bits are 0, that becomes a network address. Okay, that means what? You are directly identifying either you are talking about this network, or this network, or this one. Okay, so when you have some values in this part, network part, and no value in the host part, that means you are talking about the complete network. Okay, and if you have some value in host part, that means you are talking about a particular machine in that particular network. Okay, so we'll go back to the problem here. Given the network address is this one, so there is a difference between a network address and an IP address. IP address will have a particular value in the host part. There is some, countable value in the host part. So we are talking about the IP address if host bits are not 0. As soon as we talk about the host bits, all host bits are 0, then we are talking about the network address, or in this case, a floor address. Okay, so this is the concept. If I say 17.0.0.15, that means it is an IP address. This is a network address. Got the concept? Now let us go back to the problem. What is asked? Find the class. Class is A. Okay, and the block and the range of IP addresses. Okay, now the range of IP addresses is very good concept. Okay, range of IP address means what? What is the lowest IP address you can have, and what is the maximum IP address you can have? Okay, you cannot have all zeros in host bits. So what is the minimum value you can have here?
1.
1. Okay, in the last octave. You cannot have that minimum value in this octave. Okay, if you write this in binary format, I'm not writing the, I'm writing only the last one, 0, 0, 0, 0. You cannot have all zeros, so you are only having the minimum value, that is last bit as 1. And this will become 17.0.0.1. So that is the minimum IP address in this network. Okay, what is the maximum IP address?
17.255.255.
17 point. Can you please repeat? 255.
And then again 255.
255. Is it correct? Okay, so let us have this as a maximum value of an IP address. This is a minimum value. Okay, IP, what you can say, lower IP and the highest IP. Okay, so this becomes the range of IP addresses. In which network? In this network. Okay, again, actually, this is not possible, 255. Okay, I'll tell you the reason a bit later, but this is what the solution of this problem is. Okay, so the class of this is A. Okay, because it lies between this range. The block of this network ID is 17. Okay, and the IP address range is from 1 to 254. As I have told you, it is not. You cannot have 255 here. I'll tell you the reason bit later. Okay. Or let me tell you the reasons straight away. Okay. Do you know the concept of broadcast? What do you mean by broadcast? Anyone?
So sending the message to all the devices which are connected.
Okay, that's perfectly fine. So let me come back to the. So let's say a person in this network wants to send the data to all the machines in this network. Okay, so you'll need one IP address. Okay, if you use the IP address, which is valid in that range, that means you're talking about one particular machine. If you want to send a data to all the machines or send a message to all the machines, that becomes a broadcast message. Okay, in that case, you'll need a particular IP, which will be a broadcast IP address. Okay, and broadcast IP address is that IP address where all the host bits are 1. Okay, so when you make all the host bits, all the 24 bits as 1, this will become the broadcast IP address. Okay, so as this is the broadcast IP address, you cannot assign this IP address to a particular machine. Okay, so what is the maximum address that you can assign in this network? This is 1 less than 255. So that is 254. Got this concept?
So sir, what would be the IP address look like if it's a broadcast?
The broadcast IP address is same, 217.255.255.255. This is the broadcast IP address for this network. So let me tell you, this is the network address is 17.0.0.0. When all the host bits are 0, okay, we are talking about the digital representation. When all host bits are 0, it becomes the network address. Okay, when all the host bits are 1, it becomes the broadcast IP address. Okay, and what are the remaining IP address? IP addresses in the range 1 greater than this network address, you can assign it to the machine, and 1 less than this broadcast IP address you can assign to the machine. So this becomes the range of IP address. First, this will be the first IP in the network, and this will be the last IP in the network. See, please, try to understand whatever I'm telling you, because this information or this knowledge will be, you'll use this knowledge all the time in your career. If you have any doubts, this is a very important topic. That's why I have picked up this topic straight away to explain you before all the unit 1 and all the unit 2. And once you understand this concept, yes, sorry.
Network ID and IP address.
Can you please repeat the question? Network ID.
Can you tell the difference between network ID and IP address?
Okay, if I want to identify, let's say I have the IP address as 17.15.16.15. Okay. And if I have the IP address as 17.15.16.15. Okay. If I want to know these IP addresses are from which network, what I'll have to do is I'll have to cut down all the host part. Right. See, this is for our understanding, but for the computer, what you'll have to do is you'll have to do something to identify what is the value there in the network part. Okay, so there is a new concept called as subnet mask. Have you heard about this? So let me tell you, for yesterday's batch, I have given, yeah. So can you see the, my IP address is 172.17.62.139. Okay. So can you tell me what class is this one?
So B,
Class
class B.
Class B, because it lies between 128 to 191. That is perfectly fine,
Yes, sir.
right? But what is this subnet mask? There is also a concept called as subnet mask. Subnet mask is 255.255.255.0. What this subnet mask will give you? What is masking?
Sir, and ending with zeros so that only the required bit remains.
Perfect. So what I need here is, I don't want the, this is the IP address. I don't want the host part. What I want is the network part, correct? So in my class, how many bits are network bits? 8 bits. And host bits are 24. So given an IP address, okay, I want some data to be ANDed so that I can get only the network part. Okay, so what is that? So if you AND the data, can you give me the value of 17? Binary value for 17.
Sir, 2
2
0001
0001
Sorry, 10001 1001. Sorry.
10001. Is it that is 17?
Yes, sir.
Okay, so this is just a 5 bits. You have to add 3 because the first octet is 8 bits, right? .16.15. This is my IP address. Okay. So my first, this is the network part, correct? And this is the host part, right? So now I don't want host part because I want to find what is the network address I'm referring to. Okay, because if I am referring to complete IP address, I'm referring to a particular machine in the network. So there are multiple machines in the network. This IP address is particularly assigned to this machine. Okay. And I want to find out what is the complete network address. That means what is the floor address. Okay. So for that, I need some mechanism. So masking, as you rightly told me that if you AND the data, what data you should AND? I don't want this data, so I will AND this with 0, right? And I want this data as it is, so I will AND it with all
One.
ones, right? And these are all 8 zeros. Huh? So what is this data in decimal? It is 255.0.0.0. So this becomes the subnet mask for class A. Okay, so be it 18.15.16.15 or 17.15.16, if I want to find out which network it is from, so I'll need a subnet mask. Okay, so with this subnet mask, I can find out what is the network ID that belongs this IP address. Okay, so for class A,
Sir,
yes, any doubt?
sir, then why it is showing 255.255.255.0?
Yeah, there is a big reason behind it. That is called as subnetting concept. Okay, I'll tell you the subnetting concept in the next session. Okay, it is a very important concept. Again, let me repeat this. These two sessions, today's session and tomorrow's session, is very important. Please try to be attentive all the time during this session. And tomorrow, I request you all to do all the paperwork as I'm doing. Okay, so whatever I'm writing on the paper, you all will have to do the same thing. Whatever I'm doing on your side. Okay, this is my request. And once you understand all these concepts, all the computer network subject and if you are programming ahead in your career, all the server programming, client programming, this knowledge is very, very important, and this will help you all. So the answer to that question, I'll tell you tomorrow. Okay. So right now, what we'll do is we'll try to find out the subnet masks for class A, class B, and class C. So subnet mask for class A, 255.0.0.0. For class B, first two bits, 2 octaves, 255.255.0.0, because these two are host bits, host octaves in class B. For class C, 255.255.255.0. Okay, and I'm very sure all of you which you are using the internet, which you are using. Any doubt? All of you will be using class C, and you'll be getting this subnet mask which is configured on your machines. If you do this on your computer, open the command prompt and type this command ipconfig, and you'll get this kind of settings on your machine. Subnet mask will be 255.255.255.0. It is a class C. Okay. Now, as this is a this is a what you can say IP addressing scheme in an organization. Okay, there is some tweaks which are used here. Okay, that I'll tell you tomorrow. Okay, for now, we'll try to solve. You please try to solve these two problems as we have solved just now. Okay, sorry, the question is still pending. What is the difference between network address and an IP address? So network address refers to a group of IP address, and IP address refers to only one machine. And network address is a group of address which refers to group of machines. Now, can you please try to solve this one and give me the answers?
So class B.
Class B, that is correct. The block is what? Block means what network ID you are referring to. 132.21 is the block ID. and the range. I need the range.
One
132.21.0.1.
132.21.0.1
0.1.
and
255 to 54.
255.254. That is correct. So this is the first IP. And this is the last IP. What is the network address?
132
132.
32.21.
dot 21.
No, I'm talking about the
0.0.
network address. So it has to be 0.0.
0.0.
What is the broadcast address?
132.21.255.255.
That is absolutely correct. So please try, as soon as you get any IP address, you should be able to find out all this set of. Am I audible?
Say you are audible, but the screen is totally white.
Okay. I think my phone has got. Yeah. So yeah, you should be able to find these four values: first IP, last IP, network address, and the broadcast address. Okay. So you can find out that for each problem. For this one also, this is a which class? Obviously, it is a class C. If you are not sure what you will do, what you can do is you can convert this decimal into IP address, and you go back to this logic. As soon as you have the binary address, you find out what is this group, whether the first two bits are 10 or 110 or something like that. Okay, that is one logic. Or you can remember this division. Okay, once you know the division, or if you remember this division, then you can identify which class, right? So this is what the solution is. Again, the address range is given as wrong here. You can make it as 1 to 254. Okay, and this is the network address, and this is the broadcast address. Any doubts, guys?
No, sir.
No, sir.
So what I'll do is, let me stop the recording.